Tonight, we're exploring the strangest secrets hidden inside our solar system. From worlds where diamonds may fall like rain, to frozen oceans beneath distant alien moons. But the deeper we go, one question becomes impossible to ignore. Was our solar system truly meant to survive? Before we begin, leave a comment telling me what city you're watching from tonight. And if you could visit one world beyond Earth, which would you choose? And if you enjoy relaxing documentaries like this, don't forget to subscribe to the channel. Wherever you are tonight, I hope you have a peaceful evening among the stars. 4.5 billion years ago, the solar system did not look peaceful. There were no calm planetary orbits, no blue Earth drifting quietly around the sun, no rings of Saturn glowing softly in the darkness. What existed instead was violence on a scale so enormous that even modern astronomy still struggles to fully reconstruct it. Entire worlds were forming, colliding, melting, and disappearing before life on Earth would ever have a chance to exist. And strangely, the deeper scientists look into the origins of the solar system, the more unstable and improbable it begins to seem. It likely started inside a cold molecular cloud, somewhere in a quiet region of the Milky Way. For millions of years, this cloud drifted through darkness almost unnoticed, made mostly of hydrogen gas, traces of helium, frozen particles of dust, and the remains of stars that had died long before our sun was born. Then, something disturbed it. Some astronomers suspect a nearby supernova shockwave compressed part of the cloud. Others believe gravity alone slowly pulled denser regions inward until collapse became unavoidable. Either way, once the process began, it accelerated with terrifying speed. As the cloud collapsed, it started spinning faster, flattening into a massive glowing disk. At the center, pressure and heat rose until a young sun ignited. But the sun was not born into emptiness. Around it stretched a chaotic ocean of debris, billions of rocks, metals, frozen particles, and unstable fragments crashing together endlessly. The solar system was less like a carefully designed structure and more like a cosmic traffic accident happening for tens of millions of years. One of the strangest things is how messy the process appears to have been. Older models once imagined planets forming neatly where they currently sit today, almost like marbles placed carefully on a table. But modern evidence suggests many planets may have wandered across enormous distances before settling into their present positions. Some researchers believe Jupiter itself may have once migrated inward toward the Sun before moving back outward again in a process now called the Grand Tack hypothesis. If true, Jupiter may have completely reshaped the architecture of the solar system early on, scattering material everywhere and preventing certain planets from fully forming. That possibility changes how people think about Earth's existence. Without Jupiter's movement, Mars may not have become such a small planet. The asteroid belt may not exist in its current form. Even Earth's water distribution could have turned out differently. The solar system starts to feel less inevitable and more accidental, the product of countless unstable events somehow producing a narrow window where life became possible. And yet, even as planets formed, they remained terrifying places. Early Earth was not blue or green. It was likely covered in magma oceans, glowing beneath a thick, toxic atmosphere. Massive impacts struck constantly. Some collisions were so violent, they may have vaporized entire regions of the planet's surface. There were periods when Earth may have resembled something closer to modern-day hell than home. One collision in particular still defines our world today. Scientists believe a Mars-sized object, often called Theia, slammed into the young Earth billions of years ago. The impact was so powerful that enormous amounts of debris were blasted into orbit. Over time, that debris gathered together and formed the Moon. At least, that is the leading theory. But even now, there are strange details that remain unresolved. The Moon's composition resembles Earth's almost too closely in some measurements, leading some researchers to question whether the collision happened exactly the way current models describe it. Still, if that impact had never occurred, Earth today might be almost unrecognizable. The Moon stabilizes Earth's tilt, influences tides, and may have helped shape long-term climate patterns that allowed life to survive over immense spans of time. It is unsettling to realize that one catastrophic collision, something that would appear apocalyptic from any human perspective, may have been one of the reasons humans eventually existed at all. The deeper astronomers study planetary formation, the more they find evidence that destruction was not the exception. It was the rule. Some planets may have vanished entirely. There are simulations suggesting the early solar system could have contained additional worlds that were later ejected into interstellar space through gravitational chaos. A close encounter with Jupiter or Saturn might have been enough to fling entire planets outward forever, turning them into rogue worlds, wandering the galaxy alone in darkness. If that happened, then our solar system may actually be quieter now than it once was, a surviving remnant of something far more crowded and unstable. Even the planets that survived still carry scars from that era. Mercury's oversized metallic core suggests it may have lost much of its outer layers in giant impacts. Uranus rotates almost sideways, possibly because something enormous slammed into it long ago. Venus spins backward compared to most planets, and scientists still debate whether ancient collisions helped create that strange rotation. The solar system sometimes feels less like a finished machine and more like an old battlefield where traces of ancient disasters remain frozen in silence. And perhaps the most unsettling part is how ordinary this chaos may actually be. Modern telescopes observing distant stars have discovered exoplanet systems that seem wildly unstable. Giant planets orbiting extremely close to their stars, eccentric paths crossing dangerously near one another, worlds unlike anything in our own system. At first, astronomers thought these systems were bizarre exceptions. But now, some scientists suspect our solar system may simply represent one stable outcome among countless violent possibilities. In other words, planetary systems might naturally begin in chaos, with only a few eventually settling into long-term balance. That idea changes the emotional feeling of the night sky. The planets overhead start to seem less permanent than they appear. Stable orbits can hide ancient catastrophes. Even water, the thing most associated with life, may have arrived through violence. Early Earth was probably too hot to hold large oceans at first. Some theories suggest water was delivered later by icy asteroids or primitive comets bombarding the young planet during a period known as the Late Heavy Bombardment. For millions of years, Earth may have been under near constant attack from space debris left over from planetary formation. But scientists still debate exactly how much water came from where. Some chemical signatures in Earth's oceans resemble certain asteroids more closely than comets. Other measurements leave room for multiple sources. It is possible Earth's oceans were assembled gradually from several different cosmic origins. The water inside every ocean, every storm cloud, and every living cell may contain material older than the sun itself. And then there is another strange possibility. Some astronomers think the sun may not have formed alone. Many stars are born in clusters surrounded by stellar siblings. Over immense spans of time, these stars drift apart across the galaxy. Somewhere in the Milky Way, there could be stars born from the same original cloud as our sun, long-lost relatives moving silently through space, impossible to recognize without precise chemical analysis. The solar system, which feels isolated and unique from Earth, may once have emerged from a crowded stellar nursery filled with radiation, turbulence, and nearby newborn suns blazing in every direction. That environment may have shaped the entire history of our system. Nearby stars could have influenced orbital patterns or disturbed distant icy objects. Some researchers even suspect ancient stellar encounters altered the outer edges of the solar system long ago. The farther science pushes outward, the harder it becomes to define where the solar system truly ends and where outside influences begin. And despite everything humanity has learned, enormous uncertainties remain. Scientists still debate exactly how quickly planets formed. Some models suggest surprisingly rapid growth. Others require slower accumulation over millions of years. There are disagreements about how common Earth-like systems truly are. There are unresolved questions about why Mars stopped developing into a larger planet. There are mysteries surrounding the outer solar system that may point toward unknown massive objects still undiscovered. The truth is that the solar system does not fully behave like the simple diagrams shown in classrooms. It is stranger than that, more unstable, more improbable, more alive with motion and hidden history. When people look at the planets now, they often imagine permanence, worlds quietly circling the sun in predictable silence. But the solar system was born from collapse, fire, collision, migration, and near disaster. Entire worlds may have died so others could survive. The calm sky above Earth is not evidence that chaos never happened. It may actually be evidence that chaos somehow settled down, at least for now. For most of human history, the sun felt simple. A bright object rising every morning, warming oceans, feeding forests, lighting clouds from behind mountains. Ancient civilizations worshipped it because it seemed dependable, almost comforting. Even now, people step into sunlight without really thinking about what they are standing beneath. But the closer science moves toward the sun, the stranger it becomes. Not simply hot or dangerous, but deeply unnatural. A gigantic sphere where matter behaves in ways that almost stop making intuitive sense. And the most unsettling part may be this. the sun is still hiding enormous secrets. From Earth, sunlight feels immediate. But the light touching your skin tonight began its journey long before human civilization existed in its modern form. Inside the sun's core, atoms are crushed together under unimaginable pressure. Hydrogen nuclei collide so violently that they fuse into helium, releasing energy in the process. Every second, the sun converts hundreds of millions of tons of matter directly into energy. Yet the strange thing is that the energy created in the core does not simply rush outward. A single photon of light can spend thousands, possibly even hundreds of thousands of years trapped inside the sun before finally escaping into space. That idea barely feels real at first. The sunlight arriving on Earth in 8 minutes may actually contain energy born before the pyramids were built. Deep inside the sun, particles bounce endlessly through dense plasma like trapped echoes trying to escape a storm. Only after an impossibly slow struggle does that energy finally break free into open space. And once it does, it begins crossing a system entirely dependent on its survival. The sun contains over 99% of all the mass in the solar system. Every planet, moon, asteroid, and comet is trapped inside its gravity. In many ways, the solar system is less a collection of planets and more an extension of the sun itself. Earth is not merely orbiting the sun, it is living inside the outer atmosphere of a star. That atmosphere stretches much farther than people imagine. The solar wind, streams of charged particles constantly flowing outward, reaches beyond Pluto and forms a massive invisible bubble around the solar system called the heliosphere. Voyager 1, humanity's farthest spacecraft, spent decades moving through this solar territory before finally beginning to enter interstellar space. Even at unimaginable distances, traces of the sun still dominate the darkness. And despite its calm appearance from Earth, the sun is violent, almost beyond comprehension. Its surface boils continuously. Towering columns of plasma rise and collapse. Magnetic fields twist into impossible shapes before snapping suddenly with explosive force. Solar flares erupt with energy equivalent to billions of nuclear bombs. Coronal mass ejections can hurl enormous clouds of charged particles across space at millions of miles per hour. If one of the largest known solar storms struck Earth directly today, modern civilization could experience a level of technological disruption unlike anything in recorded history. Scientists often point to the Carrington event of 1859, the most powerful solar storm ever reliably documented. Telegraph systems sparked violently. Operators received electric shocks. Some wires reportedly continued functioning even after being disconnected from power sources because the atmosphere itself had become electrically charged. Auroras appeared over tropical regions where they should never have been visible. And that happened before satellites, internet infrastructure, GPS systems, global electrical grids, or digital banking networks existed. A similar storm today could potentially damage transformers, disrupt communications, interfere with navigation systems, and create long-lasting blackouts across enormous regions. Researchers debate how severe the consequences would truly be, but very few doubt that humanity remains surprisingly vulnerable to the moods of a star. What makes this even stranger is that the Sun is not considered unusually extreme. Compared to many stars in the galaxy, it is relatively stable. Some stars produce flares vastly more powerful. Others rotate so rapidly that their magnetic activity becomes chaotic beyond anything seen in our solar system. Red dwarf stars, among the most common stars in the Milky Way, can unleash superflares capable of sterilizing nearby planets with radiation. In that sense, Earth may orbit not a terrifying star, but one of the calmer possibilities available in the galaxy. And yet, even this calmer version still contains mysteries scientists cannot fully explain. One of the biggest is the coronal heating problem. Logically, the farther you move from a heat source, the cooler things should become. But the Sun's outer atmosphere, called the corona, is somehow far hotter than the visible surface below it. The photosphere glows at around 10,000 degrees Fahrenheit, while parts of the corona reach millions of degrees. For decades, astronomers have debated how this is possible. Some theories involve tiny magnetic explosions called nanoflares, constantly releasing hidden energy. Others suggest powerful waves moving through magnetic fields may transfer heat outward. Spacecraft like the Parker Solar Probe are now traveling closer to the Sun than any human-made object in history, attempting to solve these mysteries directly inside the corona itself. Even now, the answers remain incomplete. And there is something eerie about that. Humanity studying the object that makes life possible, while still not fully understanding how its atmosphere works. The Sun also produces sound. Not in the way humans normally experience it, since space itself is mostly silent, but pressure waves move through the Sun continuously. Scientists can detect these vibrations and convert them into audible frequencies. The result sounds haunting. Deep, resonant tones echoing from inside a giant living furnace. It changes the emotional feeling of the Sun completely. Not a flat, glowing disk in the sky, but a vibrating sphere of plasma humming endlessly through the darkness. Then there is the question of time. Stars feel eternal to human beings because human lives are short. Entire civilizations rise and disappear while the Sun changes almost imperceptibly. But the Sun is aging every second. Slowly, it grows brighter over immense timescales. Hundreds of millions of years from now, that gradual increase in luminosity may dramatically alter Earth's climate. Long before the Sun actually dies, Earth could become too hot for oceans to remain stable. Eventually, the Sun will exhaust the hydrogen fuel inside its core. When that happens, it will begin transforming into a red giant. Its outer layers will expand outward across the inner solar system. Mercury will almost certainly disappear. Venus will likely be consumed completely. Earth's fate is less certain. Some models suggest Earth may also be swallowed. Others propose the planet could spiral outward slightly as the Sun loses mass. But even in the more optimistic scenarios, Earth's surface would likely become uninhabitable long before direct engulfment ever occurred. Oceans would evaporate. Atmospheres would collapse. The familiar blue world would become something closer to scorched stone beneath an expanding red sky. And strangely, that future is not unusual. It is simply what stars do. The atoms inside your body exist because older stars once died. The iron in blood, the oxygen in lungs, the calcium in bones, all forged inside ancient stellar interiors before being scattered into space by supernovas long before the solar system formed. In a way, the sun represents both creation and destruction at the same time. Stars build the ingredients for life, but their radiation, gravity, and eventual deaths also erase worlds without hesitation. The sun itself may even influence human psychology more deeply than people realize. Human sleep cycles, agriculture, migration patterns, hormones, and entire ecosystems evolved under its rhythms. Ancient monuments from Egypt to Central America aligned themselves to solar movements with astonishing precision. Long before telescopes existed, civilizations already understood that survival depended on the sky. But despite thousands of years of observation, the sun still surprises scientists regularly. In recent decades, astronomers discovered mysterious cycles and asymmetries in solar behavior that are not perfectly understood. There are periods where solar activity becomes unusually quiet, like the Maunder minimum during the 1600s, when sunspots nearly vanished for decades. Some researchers suspect these shifts may influence Earth's climate more than previously assumed, though the relationship remains scientifically debated and complex. There are also questions about how stars behave late in life, how magnetic fields truly evolve, and whether our current solar models fully explain everything happening beneath the visible surface. The sun appears stable because humans observe only tiny fragments of cosmic time. But over millions of years, stars can change dramatically. And perhaps that is what makes the sun unsettling in a deeper way. Not because it is evil or hostile, but because it operates on scales completely detached from human instinct. Its energy sustains every forest, ocean, and living creature on Earth. Yet it could erase modern civilization through a sufficiently powerful eruption without intention or awareness. It creates life simply by existing. It destroys life just as naturally. Tonight, somewhere beyond the clouds, the sun is still burning silently in the dark, converting matter into light, bending space with gravity, sending invisible storms across billions of miles, and slowly moving toward a future that will eventually consume the worlds orbiting around it. And humanity, for all its technology, still survives entirely at the mercy of a star it barely understands. If you could stand somewhere above the inner solar system and watch the planets drift around the sun in silence, Mercury and Venus would probably look beautiful from a distance. Tiny, bright worlds glowing close to the sunlight, almost hidden inside its glare. For thousands of years, humans saw them as mysterious lights appearing near sunrise or sunset. Ancient astronomers associated Venus with love, beauty, and divine power. Mercury became linked to speed and messages because it moved so quickly across the sky. But the closer humanity moved toward these planets, the more disturbing they became. Today, scientists often describe Mercury and Venus as hell worlds, places so hostile that survival there would be almost impossible, even for machines specifically designed to endure extreme conditions. And strangely, both planets reveal something unsettling about Earth itself, because hidden beneath their heat and silence are clues about how fragile worlds can become. Mercury is the closest planet to the Sun, but it does not behave the way most people expect. Many imagine it as a permanently burning world where every surface glows red with heat. The reality is stranger. Mercury experiences some of the most extreme temperature swings anywhere in the solar system. During its long daylight hours, surface temperatures can rise above 800 degrees Fahrenheit. But at night, temperatures crash hundreds of degrees below freezing. The reason is simple and brutal. Mercury barely has an atmosphere. Without a thick blanket of air to trap and redistribute heat, the planet cannot hold warmth after sunset. Day and night on Mercury are almost like two different planets sharing the same surface. One side bakes beneath solar radiation, while another collapses into darkness cold enough to freeze gases solid. And Mercury's days themselves are deeply strange. A single day-night cycle on Mercury lasts longer than its entire year. The planet rotates so slowly that sunlight crawls across the sky in an almost surreal way. In some regions, the sun appears to rise, pause, reverse direction briefly, then continue moving again because of the complex relationship between Mercury's rotation and orbit. Standing there would probably feel disorienting beyond anything humans naturally evolved to understand. But Mercury's appearance tells an even older story. Its surface is scarred with colossal impact craters left behind from the violent early solar system. Some of these impacts were so powerful they may have altered the planet permanently. Mercury has an unusually massive iron core compared to its size, leading many scientists to suspect that ancient collisions may have stripped away much of its original outer layers long ago. In a way, Mercury might be the surviving metallic heart of a larger planet that no longer exists. And despite being so close to the Sun, hidden pockets of ice survive there. Inside deep craters near Mercury's poles, sunlight never reaches the ground. These permanently shadowed regions remain cold enough for water ice to persist for billions of years. It feels almost impossible at first. Frozen water existing on a planet close enough to the Sun to melt lead. But space is filled with contradictions like this. Temperature depends not only on distance from heat, but on exposure, atmosphere, rotation, and shadow. Mercury is harsh, silent, and ancient. But Venus is something else entirely. Venus is often called Earth's twin because the two planets are nearly the same size. From a distance, Venus could almost be mistaken for a sister world. Gravity there feels surprisingly close to Earth's. Rocky landscapes exist beneath the clouds. In some ways, Venus resembles what Earth might look like under slightly different conditions. And that possibility may be one of the most frightening things about it, because Venus became a planetary catastrophe. The atmosphere of Venus is so dense that standing on its surface would feel like being nearly a mile underwater in Earth's oceans. Temperatures climb high enough to melt lead. Thick clouds of sulfuric acid surround the planet. Winds scream through the upper atmosphere, while the surface itself remains eerily still beneath crushing pressure and yellowish darkness. The Soviet Union spent years attempting to land probes there during the Cold War. Some of those missions succeeded briefly. Grainy images eventually arrived back from the surface, showing cracked rocks scattered across a dim orange landscape beneath heavy haze. Then, the spacecraft stopped transmitting. Many survived only minutes before the environment destroyed them. There is something deeply unsettling about those photographs. They do not look dramatic in the cinematic way science fiction often imagines alien planets. Venus looks empty, suffocating, ancient, like a world where time itself has stalled beneath the weight of its own atmosphere. And yet, scientists suspect Venus may not always have been this way. Some climate models suggest ancient Venus could once have possessed oceans, rainfall, and temperatures far milder than today. Billions of years ago, it may have resembled a primitive version of Earth. But because Venus sits closer to the Sun, slightly more solar energy reached its atmosphere. Over immense stretches of time, that difference may have triggered a runaway greenhouse effect. Water vapor itself traps heat. As temperatures rose, more water evaporated into the atmosphere, trapping even more heat, which caused even more evaporation. Eventually, the process spiraled beyond recovery. Oceans disappeared. Water molecules broke apart high in the atmosphere. Hydrogen escaped into space. Carbon dioxide accumulated until the planet transformed into a furnace. If that interpretation is correct, Venus represents one of the clearest examples in the solar system of how a habitable world can become uninhabitable. But even now, scientists still debate parts of the story. Exactly how long Venus may have maintained oceans remains uncertain. Some researchers argue the planet could have lost its water very early. Others believe stable conditions may have survived for far longer than once assumed. The truth is buried beneath clouds thick enough to hide most direct observation. And Venus keeps producing mysteries. The planet rotates backward compared to most worlds in the solar system. On Venus, the sun rises in the west and sets in the east. No one fully knows why. Massive ancient impacts may have altered the planet's rotation long ago. Some theories suggest complex atmospheric effects gradually slowed and reversed the spin over immense timescales. Even after decades of study, the answer remains unresolved. Then there are the volcanoes. Venus contains enormous volcanic structures spread across vast regions of its surface. Scientists strongly suspect at least some of them may still be active today. Radar observations have revealed changes that could indicate ongoing eruptions. If true, Venus is not a dead world at all, but a living geological system hidden beneath toxic clouds. And hidden within those clouds is one of the strangest debates in modern planetary science. In 2020, researchers announced possible evidence of phosphine gas in Venus's atmosphere, a chemical that, on Earth, is often associated with biological processes. The discovery immediately triggered enormous controversy. Some scientists questioned the measurements themselves. Others proposed non-biological explanations involving unknown chemistry or volcanic activity. Follow-up observations produced conflicting results. No consensus exists. But the fact that the debate happened at all changed the emotional feeling of Venus for many people. Suddenly, this suffocating world was no longer just a dead planet. It became a place where tiny microbial life, at least hypothetically, might survive high above the inferno-like surface inside cooler cloud layers. The idea sounds almost absurd at first, yet Earth itself contains microorganisms living in acid lakes, deep underground rocks, boiling hydrothermal vents, and frozen Antarctic ice. Life repeatedly adapts to environments once considered impossible. That does not mean Venusian life exists, but it reminds scientists to be cautious about declaring entire worlds completely sterile. And perhaps that is what makes Mercury and Venus so fascinating together. They are not simply hostile planets. They are warnings about how differently worlds can evolve. Mercury shows what happens when a planet loses almost everything: atmosphere, protection, geological activity, perhaps even much of its original structure. Venus shows what can happen when climate systems spiral beneath a runaway atmosphere. Between them, Earth exists inside a surprisingly narrow balance zone. Too close to the Sun, and oceans may vanish forever. Too small, and atmospheres disappear into space. Too unstable, and surface conditions become lethal long before life has time to evolve. When people imagine hell in space, they often think of black holes or exploding stars. But Mercury and Venus feel more intimate than that, more personal. They are nearby, visible from Earth even without telescopes. Ancient humans watched them crossing the sky without realizing that beneath their brightness existed frozen darkness, acid clouds, collapsing pressure, and landscapes hot enough to destroy metal. Tonight, somewhere beneath Venus's thick atmosphere, volcanic plains still radiate heat into poisoned clouds. Somewhere on Mercury, sunlight is slowly crawling across silent craters where ice hides permanently in shadow. Two neighboring worlds orbiting the same star as Earth, yet separated from human survival by conditions so extreme they almost feel unreal. And the strangest part is that both planets may once have had the potential to become something very different. From space, Earth looks calm, blue oceans drifting beneath white clouds, continents glowing softly under sunlight, the kind of planet that seems stable enough to trust without question. People grow up believing the ground beneath them is permanent. Mountains feel ancient. Coastlines feel fixed. The sky repeats its patterns so reliably that entire civilizations built calendars around them. But the deeper scientists study Earth's history, the more unsettling the planet becomes. Because almost everything that feels stable today appears to be temporary. Earth has survived impacts capable of sterilizing continents, volcanic eruptions powerful enough to darken the sky for years, oceans that may once have frozen nearly solid, and extinction events that erased most life on the planet multiple times. The peaceful world humans inherited may not be normal at all. It may simply be a brief, quiet interval between catastrophes. In the earliest chapter of Earth's existence, the planet barely resembled the world people know now. Its surface was still cooling from constant collisions left over from the formation of the solar system. Massive asteroids and planetesimals slammed into the young Earth continuously. Some impacts released more energy than the combined nuclear arsenals of modern civilization multiplied millions of times over. Entire regions of the planet melted repeatedly beneath oceans of magma. And yet somehow, out of that violence, conditions slowly emerged where liquid water could survive. No one knows exactly when life first appeared. The evidence becomes increasingly uncertain the farther back scientists look. But some ancient rocks suggest microbial life may have existed surprisingly early, perhaps while Earth was still enduring heavy bombardment from space. If true, life on Earth began under conditions far harsher than most people imagine. The planet itself also looked different. Some researchers believe Earth's oceans may once have contained higher concentrations of dissolved iron, giving the water a darker green appearance under certain conditions. The atmosphere lacked modern oxygen levels. The sky itself may have looked hazier, tinted differently beneath volcanic gases and ancient chemistry. In a strange way, if a modern human could travel back billions of years, Earth might feel more alien than familiar, and the planet never truly stopped changing. Beneath Earth's crust, enormous tectonic plates move constantly, though usually too slowly for humans to notice directly. Continents drift across the planet over immense timescales, colliding, splitting apart, and reshaping oceans. Mountain ranges rise and erode away. Entire seas appear and vanish. Earth's surface is not fixed terrain. It is a moving system balanced on heat coming from deep below. That hidden heat occasionally escapes with terrifying force. Supervolcanoes are among the most disturbing examples. Unlike ordinary volcanic eruptions, supereruptions can eject thousands of cubic kilometers of material into the atmosphere. Ash clouds spread globally. Temperatures may drop dramatically as sunlight becomes partially blocked. Some scientists suspect ancient eruptions altered ecosystems so severely they may have contributed to population collapses among early humans. The Yellowstone volcanic system in the United States is one of the most famous examples. Despite popular disaster scenarios online, scientists do not believe an eruption is imminent. But the existence of such systems reveals something uncomfortable about Earth. Beneath forests, cities, and oceans, the planet still contains enormous reservoirs of destructive energy. And sometimes, Earth becomes dangerous in quieter ways. Around 700 million years ago, the planet may have entered one of the strangest periods in its history, a possible snowball Earth. Evidence suggests glaciers may have expanded close to the equator, freezing vast portions of the oceans beneath global ice. Exactly how complete this freezing became remains debated among scientists, but the possibility itself feels surreal. Imagine standing on a world where tropical oceans no longer exist, where sunlight reflects endlessly off frozen surfaces, where Earth from space resembles a pale white sphere drifting silently through darkness. And yet, life survived. Somehow, microorganisms endured beneath ice-covered oceans or near volcanic environments until the climate gradually shifted again. Earth repeatedly demonstrates an unsettling pattern. Conditions become catastrophic, life nearly collapses, and then the planet slowly rebuilds itself into something new. Even Earth's magnetic field behaves unpredictably. Deep inside the planet, moving liquid iron generates a magnetic shield that protects life from much of the sun's radiation. Without it, Earth's atmosphere could have eroded far more dramatically over time. But this magnetic field is not stable forever. Throughout Earth's history, the magnetic poles have reversed many times. North becomes south, south becomes north. Scientists know these reversals happened because ancient rocks preserve magnetic signatures from the periods in which they formed. What remains less certain is exactly how reversals affect life and climate while they occur. Some researchers believe the transitions may temporarily weaken Earth's magnetic shielding, though the full consequences are still debated. There is something deeply strange about the idea that even the invisible protective systems surrounding Earth can shift unexpectedly over geological time. And then there is the moon. People often think of the moon as scenery, beautiful, distant, passive. But Earth without the moon might be almost unrecognizable. The moon stabilizes Earth's axial tilt, helping moderate long-term climate variation. It drives tides that shaped coastlines and early ecosystems. Some scientists argue tidal environments may even have influenced the development of early complex life. But the moon is slowly leaving. Every year, it drifts slightly farther from Earth. The change is tiny on human timescales, measurable only with precise instruments. Yet over millions of years, it alters the Earth-Moon relationship continuously. Ancient Earth experienced shorter days, stronger tides, and a moon appearing larger in the sky than it does today. The night sky itself has not remained constant through Earth's history. And Earth's survival may also depend on another planet entirely. Jupiter's enormous gravity influences the movement of asteroids and comets throughout the solar system. In some ways, it acts as a shield, deflecting or capturing objects that might otherwise threaten the inner planets. Some scientists believe Earth has avoided far greater levels of bombardment because of Jupiter's presence. But the relationship is complicated. Certain simulations suggest Jupiter's gravity can also redirect dangerous objects inward under specific conditions. Rather than simply protecting Earth, it may both reduce and create risks depending on orbital dynamics over immense timescales. The solar system behaves less like a perfectly organized machine and more like a delicate gravitational negotiation that never completely settles. And occasionally, those negotiations fail catastrophically. Earth's history is filled with mass extinctions. Around 252 million years ago, the Permian-Triassic extinction event wiped out the vast majority of marine species and many land organisms as well. Scientists continue debating the exact chain of causes, but massive volcanic eruptions in Siberia likely played a major role, possibly triggering climate shifts, ocean acidification, and oxygen loss across ecosystems. Then came the extinction most people know best. 66 million years ago, an asteroid roughly 6 miles wide struck near what is now the Yucatan Peninsula. The impact released unimaginable energy. Wildfires spread. Shock waves circled the planet. Dust and aerosols darkened the atmosphere. Food chains collapsed. Dinosaurs, which had dominated Earth for over 160 million years, disappeared, except for the lineage that eventually became birds. But even this event contains mysteries. Scientists strongly agree the asteroid impact was central to the extinction. Yet some researchers continue discussing how volcanic activity already occurring in India at the time may also have contributed to environmental stress before or after the impact. The extinction may not have resulted from one single disaster alone, but from several overlapping crises pushing ecosystems beyond recovery. And that idea feels important when looking at Earth as a whole. The planet rarely changes for only one reason. Climate, geology, oceans, atmosphere, magnetic fields, impacts from space, all interact continuously in ways scientists are still trying to untangle. Earth is not a passive rock supporting life. It is an active system, constantly reshaping the conditions that allow life to exist. Human civilization emerged during a relatively stable climatic window known as the Holocene. Agriculture developed, cities expanded, empires rose. Modern infrastructure spread across coastlines and river systems. But compared to Earth's deeper history, this stability may be unusually temporary. Ice ages come and go. Magnetic fields shift. Asteroids still cross Earth's orbit. Supervolcanoes remain active beneath the crust. Continents continue drifting silently beneath human borders that exist only for moments in geological time. And yet, most days, the planet feels calm enough that people forget all of this entirely. Tonight, oceans still move beneath the pull of a slowly retreating moon. Tectonic plates continue grinding below continents. Somewhere deep under Yellowstone, magma chambers remain warm beneath forests filled with tourists who rarely think about what lies beneath them. In the darkness beyond Earth, asteroids still travel silently through space as they always have. And through all of it, humanity lives on a world that appears peaceful, mainly because human lives are too short to witness how restless Earth truly is. For centuries, Mars has haunted the human imagination in a way no other planet ever has. Ancient civilizations watched its reddish glow moving across the night sky and associated it with blood, war, omens, and gods. Even before telescopes existed, people sensed something strange about it. Unlike the calm silver light of the moon or the soft brightness of Venus, Mars looked restless, alive somehow, a distant ember hanging in darkness. And the strange thing is that the more humanity learned about Mars, the more emotional the planet became. Because Mars does not feel completely alien. It feels abandoned. From orbit, enormous dry valleys cut across its surface like the remains of ancient rivers. Vast canyon systems stretch for thousands of miles. Mineral deposits suggest long contact with water. Polar ice caps grow and shrink with the seasons. Beneath layers of dust and rock lies growing evidence that Mars may once have looked startlingly different from the frozen desert visible today. Billions of years ago, Mars may have possessed lakes, rainfall, flowing rivers, and perhaps even shallow seas beneath a thicker atmosphere and warmer skies. That possibility changes everything. Because if Mars once held stable liquid water, then the solar system may not have produced only one potentially habitable world. Earth may simply be the one that survived. And no one knows exactly why Mars did not. One reason may lie deep beneath the planet itself. Earth remains geologically active because its interior still produces enough heat to drive tectonic activity and maintain a powerful magnetic field. Mars, being smaller, cooled faster. Over time, its internal dynamo weakened. The magnetic field faded. Without that protection, the solar wind from the sun gradually stripped away much of the Martian atmosphere over immense spans of time. The process was probably slow enough that no single moment marked the death of Mars. Instead, the planet may have faded, its air thinning century after century, surface water evaporating or freezing underground, temperatures dropping lower and lower as the atmosphere lost its ability to trap heat. Rivers disappeared, lakes dried into mineral scars, wind slowly buried ancient landscapes beneath layers of red dust. In some ways, Mars feels less like a dead world and more like a world still remembering how to be alive. Even today, traces of its past remain everywhere. Dried delta formations resemble river systems seen on Earth. Certain rocks appear shaped by long exposure to moving water. Orbiters have detected minerals that usually form in wet environments. Every mission to Mars adds another piece to the picture, and the picture becoming clearer is strangely unsettling. Because ancient Mars increasingly resembles a place where life might once have had a chance. That does not mean scientists have discovered Martian organisms. No confirmed evidence of past or present life exists yet. But the possibility remains open enough that it continues driving enormous scientific effort. And over time, the question has evolved from, was Mars ever habitable, to something more uncomfortable. If Mars was habitable, what happened? The surface of Mars today is cold beyond what most people naturally imagine. Average temperatures hover far below freezing. The atmosphere is so thin that unprotected human blood would not behave normally in open exposure. Radiation from space reaches the surface far more easily than it does on Earth. Dust storms can grow so enormous they engulf the entire planet for weeks at a time. And yet, Mars remains strangely beautiful. Sunsets there appear blue near the sun because of how fine dust scatters light through the atmosphere. Frost forms silently across certain regions during winter. Thin clouds drift over volcanoes larger than anything on Earth. In photographs sent back by rovers, the landscape sometimes resembles remote deserts in the American Southwest, until you remember that no insects move there, no plants grow there, and no wind carries the smell of rain. Only dust. Dust covering billions of years of silence. Then there is Olympus Mons. The largest volcano in the solar system rises so high above Mars that its summit extends into an atmosphere already extremely thin. It stands nearly 3 times taller than Mount Everest. On Earth, plate tectonics constantly reshape volcanic regions over time, preventing mountains from growing indefinitely in one location. Mars lacked that same geological movement, allowing Olympus Mons to keep building upward for unimaginable lengths of time. Standing near it would likely feel surreal, the slope is so enormous and gradual that a person on the surface might not even realize they were climbing the side of the biggest volcano in the solar system. Nearby lies Valles Marineris, a canyon system stretching over 2,500 miles long and far deeper than the Grand Canyon. Some scientists think ancient water may once have moved through parts of it. Others believe tectonic forces played larger roles in its formation. Like many Martian mysteries, the answer may involve multiple overlapping processes unfolding over immense spans of time. Mars rarely offers simple explanations, and perhaps nowhere is that more obvious than in the search for water. Today, much of Mars's remaining water exists as ice trapped in polar caps or frozen beneath the surface. But researchers continue debating whether liquid water may still occasionally exist underground. Certain dark streaks observed on slopes once raised hopes of seasonal flowing brines, though newer interpretations suggest dry, granular flows may explain many of them instead. Still, the possibility of subsurface water refuses to disappear completely. That matters because on Earth, wherever liquid water exists, life usually finds a way. Microorganisms survive deep beneath Antarctic ice. They endure inside underground rock systems isolated for millions of years. Some feed on chemical reactions rather than sunlight. That realization transformed how scientists think about Mars. Even if the surface became hostile long ago, underground regions may have remained more stable. Some researchers imagine ancient microbial ecosystems retreating downward as conditions worsened above them. Others argue Mars may never have developed life at all, despite temporary habitability. Right now, both possibilities remain scientifically open, and in that uncertainty, Mars becomes emotionally powerful in a way few planets do. It represents not just another world, but another version of planetary history. A nearby example of how fragile habitable conditions may actually be. The atmosphere of Mars is also filled with mysteries that continue frustrating researchers. Methane has occasionally been detected in small amounts, then vanished again unpredictably. On Earth, methane can come from both geological activity and biological processes. Scientists remain cautious because non-biological explanations are entirely possible on Mars as well. But every unexplained chemical fluctuation immediately attracts attention because people understand what is truly being asked beneath the science. Could something still be alive there? Even the sounds of Mars deepen its strange atmosphere. NASA's Perseverance rover recorded wind moving across the Martian surface. Soft, thin, almost ghost-like compared to Earth's air. The recordings feel lonely in a way difficult to describe. Not dramatic, not terrifying, just empty. Like listening to weather on a world where nobody survived. And yet humans remain obsessed with going there. Part of that fascination comes from proximity. Mars is distant, but reachable. Unlike the outer planets, it feels physically imaginable. Space agencies and private companies continue developing plans for future human missions. Some people even imagine permanent settlements beneath domes or underground habitats protected from radiation and dust. But surviving there would be extraordinarily difficult. Humans evolved under Earth's gravity, magnetic shielding, oxygen-rich atmosphere, and biosphere. Mars offers none of those naturally. Long-term exposure to low gravity may alter human health in ways still poorly understood. Radiation poses major risks. Dust could damage machinery and lungs alike. Psychological isolation alone might become one of the greatest challenges. Still, the dream persists. Because Mars does something powerful to the human mind. It sits close enough to imagine touching, yet far enough to remain mysterious. It looks dead, yet not entirely impossible. And hidden beneath that tension is a deeper fear. The possibility that Earth and Mars once stood much closer together in terms of habitability than they do now. One world stayed alive. The other lost something essential. Tonight, cold winds still move across ancient crater rims beneath a pale salmon-colored sky. Dust devils continue spiraling silently across abandoned plains where rivers may once have flowed billions of years ago. Somewhere beneath the frozen ground, buried ice remains trapped in darkness older than human civilization itself. And orbiting nearby, above that silent world, are machines built by a species trying to understand whether Mars was always empty, or whether it became empty after something went terribly wrong. Far beyond the rocky inner planets, past the fading warmth of Mars and the drifting fields of asteroids, something enormous waits in the darkness. Jupiter does not simply dominate the solar system, it overwhelms it. More than twice as massive as all the other planets combined, Jupiter is so large that if it had gathered just a little more material during its formation, it might have ignited into a small star itself. In some ways, the solar system came surprisingly close to becoming a binary star system rather than the planetary family humans know today. And that possibility changes how Jupiter feels. Because Jupiter is not just another planet. It is the gravitational engine of the solar system, a giant world whose existence may have shaped the survival of Earth long before humans ever looked up at the night sky. From a distance, Jupiter appears beautiful. Bands of orange, white, brown, and gold wrap around the planet in endless motion. Storms swirl across its atmosphere with hypnotic elegance. Through telescopes, it almost seems calm. But that calmness disappears the moment scale becomes real. Jupiter is so enormous that more than 1,300 Earths could fit inside it. And yet, despite its size, Jupiter is not solid in the way people instinctively imagine planets to be. There may be no true surface at all. The deeper something descends into Jupiter's atmosphere, the more pressure rises until gases are compressed into forms of matter almost impossible to recreate on Earth. Hydrogen, normally the lightest and simplest element in the universe, may eventually become liquid metallic hydrogen deep inside the planet, conducting electricity like molten metal beneath crushing pressure. No human machine has ever seen this region directly, and perhaps none ever will. In 1995, NASA deliberately dropped the Galileo atmospheric probe into Jupiter. For nearly an hour, it transmitted data while descending through the clouds before the pressure and heat finally destroyed it. The probe never reached anything resembling ground. Instead, it vanished downward into layers becoming increasingly violent and alien. That detail alone makes Jupiter feel unsettling. A world so deep that falling into it would not mean crashing onto a surface, but disappearing gradually into pressure, darkness, and heat until the atmosphere itself became lethal. And above those depths, storms larger than planets continue raging. The Great Red Spot is the most famous, a gigantic storm system wider than Earth that has persisted for centuries. Early astronomers observed it hundreds of years ago, and it still spins today, though scientists have noticed signs that it may slowly be shrinking over time. Winds inside the storm can exceed 400 miles per hour. Lightning flashes through towering cloud systems. Entire atmospheric bands collide and twist around one another continuously. Yet, despite all this violence, Jupiter somehow remains strangely beautiful. Part of that beauty comes from motion itself. Nothing on Jupiter stays still for long. The planet rotates faster than any other major planet in the solar system, completing a full rotation in less than 10 hours. That rapid spinning stretches storms into colorful horizontal bands circling the globe. Watching Jupiter feels less like observing a planet and more like observing weather on a cosmic scale. But Jupiter's true power may lie not in its atmosphere, but in its gravity. Throughout the solar system, Jupiter acts almost like a giant gravitational gatekeeper. Its immense mass captures, redirects, or ejects countless objects moving through space. Many scientists believe Jupiter has protected Earth from devastating impacts by absorbing or deflecting dangerous comets and asteroids over billions of years. One dramatic example happened in 1994, when comet Shoemaker-Levy 9 collided with Jupiter after being torn apart by its gravity. Fragment after fragment slammed into the planet, releasing explosions so large they temporarily became visible from Earth. Dark scars larger than our entire planet spread across Jupiter's clouds. Watching those impacts changed something psychologically for many astronomers. It was a reminder that giant collisions are not ancient events confined to the distant past. The solar system is still active. Objects are still moving through darkness, and Jupiter continues intercepting some of them. But the relationship between Jupiter and Earth is more complicated than simple protection. Some orbital simulations suggest Jupiter can also send dangerous objects inward under certain conditions. Its gravity reshapes trajectories constantly. In some eras, it may reduce impact risks for Earth. In others, it could potentially increase them. Jupiter behaves less like a guardian intentionally defending the inner planets and more like a colossal force reshaping everything around it without concern. And perhaps it always has. Some scientists suspect Jupiter migrated significantly during the solar system's earliest days. As it moved, its gravity may have disrupted the formation of neighboring planets and scattered enormous amounts of material across space. Certain models suggest Mars remained unusually small, partly because Jupiter interfered with the distribution of matter in the early solar system. If those theories are correct, Jupiter may have helped create the conditions for Earth's survival, while simultaneously preventing other worlds from fully developing. The deeper science looks, the less the solar system feels carefully arranged. It feels negotiated. And orbiting around Jupiter are worlds that may be stranger than Jupiter itself. Europa is one of them. Beneath Europa's frozen crust lies strong evidence for a vast liquid ocean hidden in darkness. Tidal forces generated by Jupiter's gravity continuously flex the moon's interior, producing heat beneath the ice. Some scientists believe the amount of water inside Europa may exceed all of Earth's oceans combined. That idea alone feels extraordinary. An ocean world drifting silently through deep space beneath an icy shell miles thick. And because liquid water exists there, scientists cannot avoid asking the same question again and again. Could life survive in that darkness? On Earth, ecosystems thrive around deep-sea hydrothermal vents without relying on sunlight at all. Life feeds on chemistry, heat, and minerals rising from below. Europa may possess similar environments beneath its ice. No evidence of extraterrestrial organisms has been discovered, but Europa remains one of the most promising places in the solar system to search for microbial life. Nearby, another moon burns with constant violence. Io, the innermost of Jupiter's major moons, is the most volcanically active world known. Its surface erupts continuously because Jupiter's gravity stretches and compresses the moon relentlessly, generating immense internal heat. Volcanoes blast sulfur high above the surface. Lava lakes glow across alien landscapes colored yellow, red, black, and orange. Io does not feel like a normal moon. It feels like a world trapped inside geological torture. Then there is Ganymede, larger than the planet Mercury and possessing its own magnetic field, something no other moon in the solar system is known to have. Callisto, farther outward, preserves ancient craters so old that parts of its surface may barely have changed for billions of years. Together, Jupiter's moons resemble an entire miniature planetary system orbiting one giant central force. And the farther spacecraft move into Jupiter's environment, the more hostile it becomes. Radiation trapped within Jupiter's magnetic field is so intense that it can damage electronics rapidly and would likely kill unprotected humans quickly. The magnetic field itself is enormous, stretching millions of miles through space. Auroras blaze around Jupiter's poles with energies far exceeding those seen on Earth. Even space near Jupiter becomes dangerous simply because the planet exists. And still, despite all its violence, there is something strangely protective about Jupiter's presence. Without giant planets like it, planetary systems might evolve very differently. Some astronomers suspect Jupiter-like worlds help stabilize certain orbital structures over time. Others argue giant planets may actually make stable, habitable worlds rarer in some systems. The debate continues because every new exoplanet discovery seems to complicate the picture further. What remains undeniable is that Jupiter influences nearly everything around it. The asteroid belt carries traces of its gravity. Comets alter their paths because of it. Moons melt internally because of it. Even Earth's history may partly depend on it. And yet, Jupiter itself remains deeply mysterious. Scientists still do not know exactly what lies at its center. Some models suggest a dense rocky core exists beneath the metallic hydrogen. Others propose the core may have partially dissolved into surrounding layers long ago. Data from NASA's Juno spacecraft continues refining these theories, but many uncertainties remain. In some ways, Jupiter behaves less like a planet and more like an unfinished star, a giant object balanced between categories. Tonight, storms larger than Earth continue rotating through its atmosphere beneath flashes of alien lightning. Deep below the clouds, pressure crushes matter into forms humans barely understand. Europa's hidden ocean remains locked beneath ice, while Io's volcanoes continue erupting into darkness. And somewhere inside the gravitational reach of this enormous world, the history of Earth itself may have been shaped long before humans ever existed to wonder about it. If there is one planet in the solar system that seems almost unreal, it is Saturn. Even people who know very little about astronomy can recognize it instantly. The rings alone feel impossible. Enormous glowing bands suspended delicately around a giant golden world drifting through darkness. Through a telescope, Saturn does not look like something nature created. It looks designed, balanced too perfectly to be accidental. And yet, Saturn may be one of the strangest places humans have ever discovered. From a distance, the planet appears calm, almost elegant compared to the chaotic violence of Jupiter. But that calmness hides a world of enormous storms, impossible winds, hidden oceans, and moons that may contain some of the best chances for extraterrestrial life anywhere in the solar system. The first thing people notice are the rings. For centuries, astronomers struggled to understand what they were seeing. Early telescopes made Saturn appear distorted, almost as if the planet had giant handles attached to its sides. Galileo himself could not fully explain the shape. Only later did better observations reveal the truth. Saturn was surrounded by a vast system of icy rings stretching hundreds of thousands of miles through space. But the truly strange part is how thin those rings actually are. Despite their enormous width, many sections are often only tens of meters thick. In some places, perhaps even thinner. From far away, they look solid and smooth. But up close, the rings are made from countless fragments of ice, rock, and dust, orbiting together like frozen debris trapped in delicate balance. Nobody knows with complete certainty how they formed. Some scientists think the rings may be remnants of a shattered moon, torn apart by Saturn's gravity long ago. Others suggest they formed alongside the planet itself during the earliest era of the solar system. Recent evidence hints the rings might actually be younger than once believed, possibly only a few 100 million years old, rather than ancient relics from the beginning. And even more strangely, Saturn may eventually lose them. Tiny particles from the rings are slowly falling into the planet through a process scientists sometimes call ring rain. Over immense timescales, the most beautiful feature in the solar system could gradually disappear. Future civilizations, millions of years from now, might see Saturn as a plain gas giant without the glowing structures humans now consider iconic. That idea changes how the rings feel emotionally. They stop seeming eternal. They become temporary. And Saturn itself is filled with similar contradictions. The planet is enormous, yet incredibly light for its size. If there were an ocean large enough, Saturn would theoretically float because its average density is lower than water. Of course, no such ocean could exist naturally on that scale. But the concept alone makes Saturn feel less like a planet and more like a surreal object from a dream. Its atmosphere is not peaceful either. Winds race across Saturn faster than many hurricanes on Earth. Massive storms emerge and vanish across the cloud tops. Lightning flashes through deep atmospheric layers. Hidden beneath the visible haze, pressure increases downward into environments humans still barely understand. And at Saturn's North Pole, something extraordinary rotates endlessly through the clouds. A gigantic hexagon. Discovered decades ago, the hexagonal storm at Saturn's pole remains one of the most visually bizarre structures in the solar system. The shape spans thousands of miles wider than Earth itself, yet maintains remarkably stable geometric boundaries while rotating through the atmosphere. Scientists believe complex fluid dynamics and jet streams likely create the phenomenon, but seeing such a perfect polygon emerge naturally in a planetary atmosphere still feels deeply strange. It is one of those moments where the universe behaves in ways almost too artistic to seem real. Yet, Saturn's greatest mysteries may not belong to the planet itself. They orbit around it. Titan is perhaps the most haunting of them all. Larger than the planet Mercury, Titan hides beneath a thick orange atmosphere rich in nitrogen. For years, scientists could barely see its surface because dense haze covered the moon completely. Then, in 2005, the Huygens probe descended through Titan's atmosphere and revealed a world unlike anything else known. Rivers, lakes, rainfall, coastlines. At first glance, Titan almost resembles Earth, but the liquids flowing across its surface are not water. They are methane and ethane, existing as liquids because Titan is unimaginably cold. Water there behaves more like rock, frozen solid beneath the surface. Entire weather systems cycle through the atmosphere using hydrocarbons instead of water vapor. It feels like a parallel version of Earth written with different chemistry. And beneath Titan's frozen crust, scientists suspect another hidden ocean may exist. This one made largely of liquid water mixed with ammonia. That means Titan may contain two entirely different kinds of liquid environments at once: hydrocarbon seas above and possible water oceans below. No one knows what kind of chemistry might emerge under those conditions over immense spans of time. Some researchers speculate Titan could resemble a window into the chemistry that existed on early Earth before life fully developed. Others believe the moon may simply be too cold and slow for biology to advance significantly. Either way, Titan has become one of the most fascinating worlds in planetary science because it blurs the line between alien and familiar. And then there is Enceladus. At first glance, Enceladus appears small and bright, almost insignificant beside Saturn's larger moons. But beneath its frozen surface lies one of the biggest surprises in the solar system: a hidden ocean. In 2005, NASA's Cassini spacecraft observed enormous plumes erupting from cracks near Enceladus's south pole. spraying water vapor and ice particles into space. Further analysis revealed salts, organic compounds, and evidence suggesting hydrothermal activity deep below the ice. In other words, Enceladus may possess many of the ingredients scientists associate with habitable environments: liquid water, heat, chemistry, energy sources. The implications were enormous, because unlike Europa, where thick ice may complicate future exploration, Enceladus is actively ejecting material from its subsurface ocean directly into space. Spacecraft can potentially sample those plumes without drilling through miles of ice. Some scientists now consider Enceladus one of the best locations in the solar system to search for microbial life. And if life exists there, it would transform humanity's understanding of biology forever. Not because alien microbes themselves would necessarily be intelligent or complex, but because it would mean life emerged independently in more than one place within the same solar system. That possibility alone would suggest the universe may be far more biologically active than humans once imagined. Yet Saturn's moons also carry deep loneliness. Many drift through darkness beneath pale sunlight, weaker than Earth's by nearly a factor of 100. Shadows stretch across frozen plains. Rings cast moving patterns across cloud tops and ice fields. Entire oceans may exist beneath surfaces that sunlight never warms directly. Cassini revealed much of this hidden beauty. For over 13 years, the spacecraft orbited Saturn, transforming human understanding of the system completely. It captured storms swirling through golden clouds, sunlight scattering through rings, methane lakes reflecting dim skies on Titan, and icy geysers erupting from Enceladus. Eventually, with fuel running low, NASA deliberately sent Cassini plunging into Saturn's atmosphere in 2017 to avoid contaminating potentially habitable moons. Even its ending felt cinematic. A machine built by humans diving into a giant alien planet after spending years exploring worlds that might contain hidden oceans beneath frozen darkness. And perhaps that is what makes Saturn emotionally different from Jupiter. Jupiter feels overwhelming, massive, violent, almost godlike. Saturn feels distant, dreamlike, beautiful in a quieter way. Its system is filled not just with power, but with atmosphere, rings glowing against black space, orange skies over methane seas, hidden oceans beneath ice, geometry emerging from storms, tiny frozen moons drifting through shadows while carrying secrets scientists are only beginning to understand. Tonight, Saturn's rings continue orbiting silently around the giant planet, each fragment reflecting faint sunlight across billions of miles of darkness. Methane rain may still be falling somewhere over Titan's lakes. Beneath the ice of Enceladus, warm oceans may still move slowly through eternal night. And far from Earth, one of the most beautiful places in the universe continues hiding some of the deepest mysteries humanity has ever encountered. Beyond Saturn, the solar system begins to feel different. The sunlight weakens, shadows deepen. Distances grow so enormous that even light itself takes hours to travel between worlds. Out there, beyond the familiar beauty of Saturn's rings, lie two planets humans still barely understand: Uranus and Neptune, the ice giants drifting near the edge of the sun's dominion. And strangely, Despite being among the largest planets in the solar system, they remain some of the most mysterious. Part of the reason is distance. Jupiter and Saturn have dominated human attention for centuries, filling telescopes with dramatic storms and bright rings. But Uranus and Neptune sit so far away that even powerful observatories once saw them as little more than faint colored disks in darkness. Only one spacecraft in human history has ever visited them directly: Voyager 2. That single brief encounter in the 1980s still shapes much of what humanity knows about these worlds today. Which means, in a very real sense, the outer solar system remains largely unexplored. Uranus is the first of the ice giants, and almost immediately it breaks expectations. Most planets spin like tops, rotating roughly upright as they orbit the Sun. Uranus does not. It lies almost completely on its side, tilted about 98 degrees, as though some enormous force knocked the planet over long ago. Scientists suspect a massive collision early in the solar system's history may have caused it. Perhaps a world larger than Earth slammed into Uranus billions of years ago, permanently altering its rotation. Other theories suggest multiple smaller impacts gradually shifted the planet over time. No one knows for certain. But the result is extraordinary. For long stretches of its orbit, one pole of Uranus points almost directly toward the Sun, while the other remains in darkness. Seasons there last more than 20 years each. Entire hemispheres experience decades of continuous daylight, followed by decades of night. It is difficult for the human mind to fully picture a sunset that does not return for generations. And, despite its calm appearance in photographs, Uranus may hide surprisingly violent conditions beneath its pale blue clouds. The atmosphere contains hydrogen, helium, and methane. The methane absorbs red wavelengths of light, giving Uranus its eerie cyan color. But far below the visible atmosphere, pressure rises into strange states of matter scientists still struggle to model precisely. Temperatures and forces become extreme enough that exotic chemistry may unfold deep inside the planet. One of the most fascinating possibilities involves diamonds. Some researchers believe enormous pressure inside Uranus and Neptune may break apart methane molecules, compressing carbon atoms into crystalline structures that sink downward through the planets like rain. In other words, somewhere deep beneath the clouds, diamonds may literally fall through darkness toward hidden interiors. The idea sounds almost fictional, yet physics suggests it may be possible. And that feeling appears repeatedly in the outer solar system, reality behaving in ways so strange they almost feel invented. Neptune, even farther from the Sun, feels stranger still. At that distance, sunlight becomes weak and cold. Yet, Neptune possesses the fastest winds ever measured in the solar system. Storms race through its atmosphere at speeds exceeding 1,200 miles per hour. That means some winds on Neptune move faster than the speed of sound on Earth. No one fully understands how a planet receiving so little solar energy can produce weather so violent. Part of the answer may lie within Neptune itself. Unlike Uranus, which radiates relatively little internal heat, Neptune emits significantly more energy than it receives from the Sun. something inside the planet continues generating or retaining heat, driving atmospheric motion across the frozen world. But exactly how that internal system operates remains uncertain. And uncertainty defines almost everything about these planets. The famous Great Dark Spot observed on Neptune by Voyager 2 resembled Jupiter's Great Red Spot, a massive storm system swirling through the atmosphere. Yet when astronomers later searched for it using the Hubble Space Telescope, it had vanished completely. Other dark storms appeared elsewhere instead. Entire planetary weather systems emerge and disappear in silence, while humanity watches from billions of miles away. The farther outward the solar system extends, the more temporary everything begins to feel. Even sunlight itself changes emotionally at those distances. On Earth, daylight floods landscapes brightly enough to define every shape and shadow. But near Neptune, the sun appears more like an intensely bright star than a warm presence filling the sky. Noon there would resemble a dim Earth twilight, despite being daytime. And still, these worlds continue orbiting through darkness year after year, century after century. Voyager 2 revealed much of this hidden beauty during its flybys. Uranus appeared pale and strangely empty at first glance, almost featureless compared to Jupiter and Saturn. But later observations detected subtle atmospheric activity, thin rings, and complex magnetic behavior. Neptune surprised scientists even more, displaying dynamic storms and active weather despite its extreme distance from the Sun. Perhaps the most unsettling thing Voyager revealed was how little humanity truly knew. These giant planets had existed since the formation of the solar system, yet one passing spacecraft transformed understanding almost overnight. Entire categories of atmospheric behavior, magnetic fields, and moon systems remained hidden until the late 20th century, and their moons deepened the mystery even further. Triton, Neptune's largest moon, may be one of the strangest objects in the solar system. Unlike most major moons, Triton orbits backward relative to Neptune's rotation, suggesting it may not have formed there originally. Many scientists believe Triton was once an independent object captured by Neptune's gravity long ago, possibly originating from the Kuiper belt beyond. Its surface is frozen and extraordinarily cold, yet Voyager discovered evidence of active geysers erupting nitrogen gas into the thin atmosphere. Even near the edge of the solar system, geological activity still survives. And because Triton slowly spirals inward toward Neptune over immense timescales, one distant future possibility is especially haunting. The Moon may eventually be torn apart by Neptune's gravity, potentially forming enormous rings around the planet billions of years from now. The outer solar system is filled with events unfolding so slowly that entire civilizations would rise and disappear before noticing meaningful change. Even the magnetic fields of Uranus and Neptune behave oddly. Unlike Earth or Jupiter, their magnetic fields appear dramatically tilted and offset from the planet's centers. Scientists still debate exactly why. Internal oceans of electrically conductive fluids may play roles, but current models remain incomplete. The deeper researchers investigate these planets, the more alien they become. And perhaps that alienness matters more than people realize. Because when astronomers search for planets around distant stars, they repeatedly find worlds similar in size to Uranus and Neptune. Ice giant planets may actually be among the most common types of planets in the galaxy. In a strange way, humanity may understand the rare rocky inner planets better than these enormous worlds that could dominate planetary systems across the universe. Yet, despite their importance, Uranus and Neptune remain largely untouched. No orbiters currently circle them. No landers descend into their atmospheres. Human knowledge still depends heavily on a spacecraft that passed by decades ago and continued onward into interstellar space. There is something almost lonely about that. Two giant worlds drifting at the edge of the sun's influence, carrying storms, hidden oceans, strange magnetic fields, and impossible chemistry, while barely visited by the civilization trying to understand them. And beyond Neptune, the darkness only deepens. The Kuiper Belt begins stretching outward into regions where sunlight grows fainter still. Icy objects drift silently through ancient cold. Farther beyond may lie distant planets not yet discovered, rogue worlds wandering unseen, or remnants left over from the solar system's earliest chaos. Tonight, somewhere in the endless twilight near Neptune, supersonic winds are still moving across blue storms beneath freezing clouds. Deep inside Uranus, pressure may still be compressing carbon into falling diamonds hidden forever from sunlight. And at the far edge of human exploration, the ice giants continue circling the darkness. Enormous, silent worlds reminding humanity how much of its own solar system remains unknown. Far beyond the major planets, where sunlight becomes thin and distant, the solar system begins dissolving into darkness. The familiar worlds disappear behind enormous stretches of empty space. Temperatures fall toward extremes almost impossible to imagine. Out there, countless objects drift silently through the cold, fragments left over from the formation of the solar system, frozen survivors from an era before Earth even existed. And somewhere in that darkness, there may still be things humanity has never seen. For a long time, people imagined the solar system ending neatly with Neptune, a final blue planet marking the outer edge of the sun's domain. But modern astronomy revealed something stranger. Neptune is not the ending at all. It is more like the beginning of a vast frontier filled with wandering worlds, ancient ice, invisible debris, and objects moving through darkness on orbits so enormous that a single year can last longer than human civilization itself. Pluto was the first major clue. When astronomers discovered Pluto in 1930, many believed they had finally found the mysterious Planet X predicted to exist beyond Neptune. But Pluto turned out to be smaller than expected, a frozen world less than half the width of the United States. Over time, astronomers realized Pluto was not alone. Similar icy objects began appearing farther out in space, hidden within a region now called the Kuiper Belt. Suddenly, Pluto stopped looking like an isolated final planet. It became part of a much larger population. The Kuiper Belt stretches beyond Neptune like a frozen ring filled with ancient remnants from the solar system's formation. Some objects are tiny chunks of ice and rock. Others are large enough to become nearly spherical worlds. Many remain undiscovered because sunlight out there is so faint that these objects barely reflect enough light to detect. And some of them behave strangely. Certain Kuiper Belt objects follow elongated, tilted orbits, difficult to explain through known gravitational interactions alone. That mystery eventually led to one of the most debated ideas in modern astronomy: the possibility of a hidden ninth planet far beyond Neptune. Planet 9, if it exists, may be a world several times more massive than Earth, orbiting so far away that one trip around the Sun could take thousands of years. Scientists have not directly observed it yet. The evidence comes mostly from unusual orbital patterns among distant objects that appear oddly clustered together. Some astronomers argue these patterns strongly suggest an unseen planet shaping the outer solar system through gravity. Others believe observational bias or alternative explanations may account for the data instead. Right now, no scientific consensus exists, but the possibility itself changes how the outer solar system feels, because it suggests humanity may still not know how many planets orbit its own sun. And farther beyond the Kuiper Belt lies something even more mysterious: the Oort cloud. Unlike the flattened structure of the planetary system, the Oort cloud may surround the solar system in a gigantic spherical shell, extending perhaps nearly halfway to the nearest stars. No human has ever directly observed it. Its existence is inferred mainly because of long-period comets entering the inner solar system from distant directions. If the Oort cloud exists as currently imagined, it contains trillions of icy objects drifting in near total darkness. Some may have remained untouched since the solar system formed billions of years ago. Others may occasionally become disturbed by passing stars or gravitational interactions, slowly falling inward toward the sun over immense periods of time. When that happens, they become comets, frozen travelers suddenly awakening as sunlight heats their surfaces. And comets are stranger than they first appear. People often describe them as dirty snowballs, but they are more like cosmic time capsules. Inside them may survive ancient material older than Earth itself, preserved in deep cold since the earliest moments of planetary formation. Every comet entering the inner solar system carries chemistry from a nearly forgotten era of cosmic history. Some scientists even suspect comets may have helped deliver water or organic molecules to early Earth. In that sense, part of life's story may have begun with wandering objects drifting through darkness long before humans existed. But the solar system's distant objects are not always gentle visitors. Earth's history contains repeated evidence of catastrophic impacts from space. The asteroid that contributed to the extinction of dinosaurs is only the most famous example. Throughout geological history, impacts have altered climates, reshaped ecosystems, and possibly redirected the evolution of life itself. And many dangerous objects still exist. Thousands of near-Earth asteroids are currently tracked by astronomers. Most pose no immediate threat, but new objects continue being discovered every year, reminding humanity that the solar system remains active and unfinished. Large impacts are rare on human timescales, yet over millions of years, they become almost inevitable. There is something unsettling about that realization. modern civilization often feels permanent, but Earth still moves through a cosmic shooting gallery filled with ancient debris left over from planetary formation. Some asteroids are also unimaginably valuable. Certain metallic asteroids may contain enormous quantities of nickel, iron, platinum, gold, and rare elements. Estimates for the theoretical value of some objects become so extreme they almost stop sounding meaningful in human economic terms. Entire industries now discuss the future possibility of asteroid mining, though enormous technical challenges remain. And hidden inside those discussions is a strange emotional shift. Humanity has begun looking at wandering objects in deep space not merely as dangers or curiosities, but as future destinations. Yet the farther outward science looks, the stranger these wandering worlds become. Sedna is one example. Discovered in 2003, Sedna follows an extraordinarily elongated orbit, carrying it far beyond the Kuiper Belt into regions of darkness where the sun becomes little more than a brilliant star. One orbit takes over 11,000 years. At its most distant point, Sedna drifts so far from the sun that the solar system itself must appear dim and small against the galaxy. No one fully understands how Sedna ended up on such an unusual orbit. Some theories suggest interactions with unseen planets. Others propose that passing stars disturbed the outer solar system long ago, while the sun still existed within its original stellar nursery. There are even hypotheses involving ancient encounters with rogue planets drifting through interstellar space. Again and again, the outer solar system refuses to become simple. And perhaps the strangest possibility of all involves worlds that no longer belong to any star. Rogue planets. Planets wandering freely through the galaxy without sunlight or solar systems may actually be common. Some could have formed normally around stars before being ejected during chaotic gravitational interactions. Others might have formed independently from collapsing gas clouds without ever orbiting a star at all. The Milky Way may contain billions of these dark, wandering worlds. Some scientists even speculate that certain rogue planets with thick atmospheres or internal heat sources might sustain hidden subsurface oceans despite drifting through interstellar darkness. The idea sounds almost impossible. Isolated worlds carrying internal warmth while traveling endlessly between stars. Yet, physics does not entirely rule it out. That possibility changes the emotional scale of the universe. Space stops feeling empty. Instead, it begins to feel filled with invisible travelers crossing darkness for billions of years. And humanity itself has now created wandering objects of its own. Voyager 1 and Voyager 2 continue moving outward beyond the planets, carrying golden records filled with sounds and images from Earth. The spacecraft are unimaginably distant now, drifting through the outer boundaries of the sun's influence toward interstellar space. Long after Earth's cities disappear, those machines may continue traveling silently through the galaxy. Tiny artificial remnants of a species that briefly existed around one ordinary star. And maybe that is what makes the outer solar system feel so haunting. The farther outward the journey goes, the more fragile human civilization begins to seem. Planets become rare, sunlight weakens, time stretches into scales difficult for the human mind to hold on to. Entire worlds drift through darkness unnoticed for billions of years. Tonight, frozen objects continue orbiting silently beyond Neptune, beneath skies where the sun barely glows. Somewhere in the distant Kuiper Belt, ancient ice still preserves material from the birth of the solar system. Farther out, comets sleep in darkness so deep they may not return toward the sun for millions of years. And beyond all of them, hidden in the cold and silence, there may still be worlds humanity has not discovered yet. The deeper humanity explores the solar system, the stranger it becomes. At first, it seems understandable. Planets orbiting a star in predictable paths, moons circling planets, gravity holding everything together in elegant order. But beneath that appearance lies something far more unsettling. The solar system is not stable in the way humans instinctively imagine stability. It is dynamic, temporary, and filled with mysteries that science still cannot completely explain. And perhaps the strangest part is that humans evolved inside it without truly realizing how unusual it is. Space itself feels silent to human beings because sound cannot travel normally through a vacuum. Yet, the solar system is constantly vibrating with invisible activity. Magnetic fields ripple through charged particles. Plasma waves move outward from the sun. Planets generate radio emissions powerful enough to be detected across millions of miles. When scientists convert some of these electromagnetic signals into sound, the results feel eerie. Whistles, pulses, deep mechanical groans echoing from worlds that have no air. Jupiter produces radio storms so intense they were first discovered accidentally by astronomers listening for static. Saturn emits strange rhythmic signals linked partly to interactions with its magnetic field and moons. Even Earth sings in its own way through auroras and magnetic disturbances. The solar system is not truly silent. Humans are simply not built to hear most of it. And the farther outward one travels, the stranger the scale of reality becomes. On Earth, distance feels manageable because human life evolved around walking, driving, or flying across landscapes. But in space, even light, the fastest thing known in the universe, requires time to move between worlds. Sunlight takes more than 8 minutes to reach Earth. To Jupiter, more than 40 minutes. To Neptune, over 4 hours. That means when sunlight touches the clouds of Neptune, it began its journey before many people on Earth had even finished eating breakfast. Space quietly stretches time into something almost difficult for the human mind to emotionally grasp. And gravity distorts it even further. According to Einstein's relativity, time itself changes under different gravitational conditions. Clocks move slightly slower closer to massive objects. Around Earth, the effect is tiny, yet measurable enough that GPS satellites must account for relativistic corrections constantly to remain accurate. Near neutron stars or black holes, the distortions become extreme. Even inside our own solar system, reality itself does not move at exactly the same pace everywhere. That realization changes the emotional feeling of space. The universe stops behaving like a fixed stage where events unfold identically for everyone. Time becomes flexible, relative, dependent on gravity, speed, and location. And despite centuries of observation, humanity still knows remarkably little about the solar system compared to what remains hidden. The ocean floors of Earth are still incompletely mapped. Underground oceans may exist beneath multiple moons. Entire populations of distant objects remain undiscovered beyond Neptune. Scientists continue identifying new moons around giant planets. Every few years, another surprising phenomenon appears: strange atmospheric chemistry, unexpected geological activity, unexplained orbital behavior. The solar system repeatedly reminds humanity that familiarity is not the same thing as understanding. And perhaps nothing captures that better than Voyager. In 1977, NASA launched 2 small spacecraft carrying golden records filled with sounds and images from Earth. Greetings in dozens of languages, music, natural sounds, human laughter, heartbeats, whale songs. The spacecraft traveled past the outer planets, revealing worlds more strange and beautiful than most scientists expected at the time. Then they kept going. Today, Voyager 1 and Voyager 2 are farther from Earth than any human-made objects in history. Their signals travel for many hours before reaching Earth. The spacecraft move through darkness so immense that nearby stars still remain incredibly distant points of light. Eventually, long after human civilization changes or disappears, Voyager may continue drifting silently through the Milky Way. Tiny machines carrying fragments of Earth into interstellar space. And hidden inside that image is another strange possibility. Humanity may not be alone in looking outward. The solar system itself appears relatively ordinary in some ways. One average star among hundreds of billions in the galaxy. Yet modern astronomy has revealed that planets are astonishingly common. Many stars possess planetary systems. Some contain rocky worlds within habitable temperature zones. Others host giant planets orbiting strangely close to their stars, or wandering in chaotic arrangements unlike anything seen around the Sun, which raises an unavoidable question. If planets are common, could life be common too? No confirmed evidence of extraterrestrial civilizations exists. Scientists remain cautious because the universe is vast, and absence of evidence is not proof either way. Yet, the numbers themselves create tension. There are billions of stars in the Milky Way alone, many older than the Sun. Statistically, it feels difficult for some researchers to imagine Earth as the only place where intelligence emerged. And yet, the silence remains. This contradiction is sometimes called the Fermi paradox. If intelligent civilizations are possible, where is everybody? Possible answers range from hopeful to deeply unsettling. Maybe intelligent life is extraordinarily rare. Maybe civilizations destroy themselves before spreading far into space. Maybe communication across cosmic distances is harder than humans assume. Some theories suggest advanced civilizations may become invisible by choice or evolve beyond technologies humans currently recognize. Others wonder whether humanity is simply too early or too late. The solar system suddenly feels less isolated and more uncertain, and even its future remains unstable. People often imagine planetary orbits as permanent, but over immense spans of time, gravitational interactions slowly alter trajectories. Computer simulations suggest the solar system is mostly stable for billions of years, Yet tiny uncertainties can grow chaotically over very long timescales. Some models even show small possibilities of planetary orbits becoming unstable in the distant future. Mercury is especially vulnerable because of its interactions with the Sun and neighboring planets. In certain simulations, its orbit eventually becomes chaotic enough to risk collisions or ejections over billions of years. The probabilities remain low, but the fact that such outcomes are physically possible reveals something profound. The solar system is not frozen. It evolves continuously, and eventually, the greatest change of all will come from the Sun itself. As the Sun ages, it will expand into a red giant, altering or destroying much of the inner solar system. Oceans on Earth may vanish long before the planet itself is consumed. Outer planets will warm temporarily beneath the expanding star. Icy moons may briefly experience liquid conditions near their surfaces. The entire architecture of the solar system will transform. Then, the Sun will shed its outer layers and collapse into a white dwarf, a dense stellar remnant glowing faintly in darkness. The worlds orbiting it, if any survive, will circle a dead star. And yet, even that may not be the ending. Stars pass near one another across galactic time. Rogue planets drift between systems. Gravity reshapes orbits continuously. Some distant future object may one day disturb the outer solar system again, scattering frozen worlds into interstellar space. The history of the solar system has always involved movement, migration, collision, and change. Perhaps permanence was never part of the design. And maybe that is what ultimately makes the solar system feel so strange. It appears calm because human lives are short. A person can spend an entire lifetime beneath the same moon, the same planets, the same constellations, never noticing how dynamic everything truly is. But over millions and billions of years, worlds freeze, atmospheres vanish, moons drift away, impacts reshape planets, stars brighten and die. The solar system is not a finished place. It is an ongoing event. Tonight, invisible radio waves are still moving through planetary magnetic fields. Voyager continues traveling outward into darkness. Somewhere beyond Neptune, frozen objects orbit silently beneath faint sunlight. Deep below the clouds of giant planets, storms continue rotating through alien atmospheres, while hidden oceans move beneath ice-covered moons. And here on Earth, a species made from ancient star matter looks upward from one small planet, trying to understand the enormous system that created it, while still barely understanding how strange that system truly is. Thank you for spending this journey through the solar system with me tonight. I hope these mysteries helped you relax, drift away, and see the universe a little differently. And if you enjoyed this documentary, don't forget to subscribe to the channel so you won't miss any future journeys into space, history, and the unknown. Wherever you are tonight, sleep well and keep looking up at the stars.